Hey, good morning, everyone. Today we're going to start looking again, or I guess continue looking again, at binomial distributions. And we're going to learn more calculator functions, hopefully to make this a little bit easier. So let's get started over here. So this would have been the fun part of the class where I would say something like, hey, it's time for a pop quiz. But we're not really going to do a pop quiz here. The idea here is that if we were in class, we would take this pop quiz. It's a 5 multiple choice questions, and then each question would have 5 answers, A through E. Basically, it's just a regular Scantron test. So the bad news is you weren't supposed to be able to see the questions, so you just have to guess on all of them. And based on how many you guessed on these 5 questions, how many would you get correct? So actually, I'm not that lucky with these kinds of things, and if I'm just guessing, I got 1 correct. So let's see. Is X a binomial setting? X is a number of correct guesses. Well, let's just go through all of bins to see if this is a binomial setting. Well, B is this binary, and there are only 2 options here. Even though there are 5 options on the quiz, really we're only interested in correct or not correct. So this is binomial. I are each question independent, and since past answers do not affect the current outcomes, then we would say yes, this is independent. N, what is the set number of trials? And we're doing 5 questions, so N is 5. And finally, S, do we have the same probability of success for each one of these options? And yes, every question has a 20% probability of being correct. That's 1 out of 5. 1 divided by 5 is 0.2. So this is a binomial setting. Something which we didn't learn yesterday was this shortcut right down over here. If X is a binomial setting, then it's often, in fact, you really should do this every time. Write down X is equal to capital B 5, 0.2. That's N, and then P at the end there. And that's shorthand, so you don't actually have to write the word binomial every time. Shorthand for X is a binomial situation. N is 5, P is 0.2. Next, calculate the probability of getting exactly 2 correct. We learned last time that we could write 5 choose 2, 0.2 to the second power, 0.8 to the third power, and that gives me 0.2048. But there is another way of doing this. If we grab our calculator and go to second vars, which is the distribution menu, and we scroll down, we will see binomial PDF and binomial CDF. Right now, we're going to stick with binomial PDF. If you use it a lot, you probably would just memorize that this was A, and you'd push alpha A every time you wanted binomial PDF. So, putting in binomial PDF, look how nice this menu looks. We have 5 trials. The probability of success is 0.2. And we're interested in 2 successes. Paste and push enter. And 0.2048. A lot of you are going to find that easier to do than the other way. Although, to tell you the truth, the other way isn't exactly difficult. It's just it's more key presses. So you're free to use this function as well. So here are the 2 different ways of doing this on your calculator. Probability of k successes is equal to nck p to the k power and 1 minus p to the n minus k power. Or if you like, you can use binomial PDF npk. All right. Using that, we can just go ahead and do this next part, would be to fill in the table showing the probability that getting exactly X correct. So again, we'll go to our calculator, And it's really not a big deal just to go up here and change all of these values. There's 0, and then we'll change this to 1. And then just go all the way down the line, 0 to 5, and get all of those values. So this is what we come up with after doing all of that. And if you look at it, doesn't that just look like a discrete probability distribution? And yes, this is actually just a discrete probability distribution. There's nothing different about it. So we can go ahead and find and interpret the mean of this distribution the old-fashioned way. If we put our values into L1 and L2, go back to the home screen and do, stat, calculate one var stats, frequency list is L2, that should give us the mean, and the mean is 1. Standard deviation is 0.89. Here is that exactly that old way. The mean is all of our numerical outcomes multiplied by our probabilities. We come up with a 1. So the mean of the binomial distribution, and this is a shortcut way of doing it. You don't actually, if you know you have a binomial distribution, then the way that you could find the mean is just n multiplied by p, which is just 1. Now, a lot of you probably would have thought about that already. I mean, if the probability of a success is 0.2 and there are 5 trials, then it makes sense that then you should get on average 5 times 0.2 correct. Interpret that. Well, after many quizzes, the average number of correct answers out of 5 questions is about 1. So to get you looking at what's the important here is this right here. That is our formula for the mean of a binomial distribution. Next, how about that standard deviation of the binomial distribution? And we found that already on our calculator. It was 0.894. Well, we could go about it that way, or we can see that there is actually a formula for the standard deviation of a binomial distribution. It is a square root of n times p multiplied by 1 minus p, and that gives us the 0.894, a little bit easier. Interpretation. The number of correct answers on a 5-question quiz typically varies from the mean by about 894. How about what's the probability of getting at most 3 correct? That probability can be interpreted as the probability that x, the number of correct answers, is less than or equal to 3. So we just need to look for how many of the outcomes correspond with x being less than or equal to 3. And that's the outcomes 0, 1, 2, and 3. And we know the probabilities that are associated with those outcomes. So we can just add all of those outcomes, all of those probabilities together, and that gives us a 0.99328. If we get to our calculator, we actually have a calculator shortcut for that as well. And the calculator shortcut for this one is, let's scroll to it. It's the other binomial one that you saw, binomial CDF. Now in a binomial CDF, it calculates the probability of less than or equal to. So basically exactly what we did. So the probability of less than or equal to 3 is exactly equal to this binomial CDF. Same response, same answer. And we could write the probability that x is less than or equal to 3 is equivalent to the binomial CDF with n equal to 5, p equals 0.2, and x equals 3. and get that same response. Okay, well, how about the probability of getting 3 or more correct? For this one, let's go back up here and see 3 or more correct. Which outcomes correspond with 3 or more correct? Well, they would be these yellow ones. And then the complement of that, everything else from that, would be this one right here, 0, 1, and 2. Now, it's important for us to think about the complement here because on our calculator, there is no function for greater than or equal to. We always have to use less than or equal to. But if we know the complement is 2 or less, then we can use our calculator kind of craftily to figure out the correct answer. So if we want to figure out the probability of 3 or more, we could actually just do 1 minus the probability of 2 or less, which is nice because 2 or less has a calculator function for it. It's the binomial CDF, n equals 5, p equals 0.2, and x equals 2. And that calculates 0.0572. If I want to calculate the probability that x is greater than or equal to 2, then I need to do 1 minus the probability that x is greater than or equal to 1. However, if I want to calculate the probability that x is strictly greater than 2, then I have to say 1 minus the probability that x is less than or equal to 2. Basically, 2 needs to be part of either the left side or the right side. And if 2 isn't included on the left, then 2 has to be included on the right. Just like up here, since 2 is included on the left side, 2 cannot be included on the right side. So all of those together takes us to our important ideas. And we did a lot of them today. So at some point we're going to have to describe a binomial distribution. So for the shape, you do want to make a histogram, but generally speaking, if p is less than 0.3, you're going to have a right-skewed distribution. And if p is greater than 0.7, you're going to have a left-skewed distribution. But again, make a histogram, make sure you're seeing what you're seeing, because some of that has to do with the sample size as well. Now for the center, that's just going to be mu, and mu is n times p like we saw before. And for the variability, we're going to use the sigma, which is the square root of n times p multiplied by 1 minus p. Now when you do interpretations, make sure you indicate the number of trials. And the interpretations are basically the same ones that we have been using for means and standard deviations all the way throughout. We have a couple of calculator notations. So if x is equal to a binomial distribution with n and p, then the probability that x is equal to k, that's binomial PDF. Make sure that we notice that that's PDF. And then for x less than or equal to k, we need to do a binomial CDF. Now, if you need to do the probability that x is greater than k, then you need to pay attention to whether or not this is greater than or less than, and then use a CDF with the 1 minus. Now, Mr. Miller's class is very difficult. It's so hard that when he gave a pop quiz recently, the students guessed on every question. Sounds familiar. Each student in the class guesses from an answer from A through E on 10 multiple choice questions. Hannah is one of those students in the class, and let Y be the number of questions that Hannah answers correctly. Question 1. Is this a binomial setting? And just like the pop quiz we did before, this is also a binomial distribution. Is it binary? Yes. Correct or incorrect? Independent? Yes. Past questions do not affect current outcomes. Do we have a number of trials? Yes. N equals 10. And does every trial have the same probability of success? Yes. P equals 0.2. Next, use technology to make a histogram of the probability distribution for y, describe its shape. So we're going to apply what we learned in our calculator over here. The first thing that we have is all of our probabilities, or all of our outcomes here in L1. Now for L2, I'm going to scroll up to the top and I'm going to push enter. And if your list is empty, you should just have this blank here, and that's kind of what you want. And what we want to put there is a binomial PDFs. So we got to scroll down to A. So we want binomial PDF. With 10 trials, probability of success is 0.2. And the X value, where we evaluate, we want that to be whatever is in L1. So when you paste that, this is what you get. List 2 is equal to the binomial PDF 10.2 and list 1. So we'll just push enter there, and that will give me the entire binomial probability. That's actually quite beautiful, I think. Probability of success was 0.2, so we should expect to see a right-skewed distribution. Now we're going to go ahead and put this onto our stat plot. Turn it on, and we want a histogram, so we're going to histogram. Just like before, we're going to put list 1, L1, and our frequency is going to be L2. Now, we're going to do something else special. We're going to go to Window, and our X-min is going to be 0.5. Our X-max is going to be 10.5, and we want each bar width to be 1. Now, as far as the height goes, we should probably make this negative 0.1, and we'll make this, I think the largest bar was probably 0.4. So let's make this 0.5, and let's see when we push graph how that's going to look. Yeah, that looks great. Oh, looks like I have some calculus left over here. Let me get rid of that. Great. So here's our histogram. This looks pretty great, actually. And as expected, we have a right-skewed distribution. So let's copy and paste this into our work. That frequency list, that really helps out for all of these. Okay. So that distribution of correct responses on a 10-question multiple choice test is right-skewed. Next, let's calculate and interpret the mean of y. That formula, again, was mu y equals n times p. In this case, that's 10 times 0.2, or just 2. Interpretation: if we took many 10-question multiple choice tests, the average number of correct answers would be 2. Again, make sure you write down how many trials there are. It's a 10-question test, so we have to do a lot of 10-question tests. The next one here is standard deviation. That formula, again, is the square root of n times p times 1 minus p, or in our case, 10 times 0.2 times 0.8. That gets me a 1.265 standard deviation. So the number of correct answers on a typical 10-question test will vary from the mean of 2 questions by about 1.265 questions. So that's all we have for you today on our binomial distribution. Believe me when I say that this is actually quite a bit, and if you've mastered this already or you feel like you have a good handle on it, good for you. I'll see you next time. Have a good one.